warm welcome. Hello my 10th class champions, a very warm welcome in this today's live session. Hi everyone, I hope you all are doing great. Let me know if I'm audible and visible. We'll just wait for everyone to join. Hello everyone. I hope you all are excited for this live session today. This is our first live for physics and we'll look into very important 4 chapters. So I want you supercharged for this live. I want you to grab your pen and paper so that we can start this live as soon as possible. Hi everyone. Hello. We are going to start our journey towards 95 plus in physics. So we'll look into mainly very important 4 chapters today, which are light, electricity, magnetic effects of electric current and human eye. We'll look into hi Rohit, hi T Trev, hello. We are going to look into these 4 chapters, guys. I want you to share this link with your friends, with your cousins who are also gearing up for boards. So we'll start. We'll look into most debated PYQs and we'll look into competency based questions and some highly weighted numericals. Okay, let's start. We'll go chapter wise. So grab your pen and paper because this is physics and you'll have to solve some questions. Okay, let's start with our first chapter, electricity, that we're going to look into. The first question, okay, this is the most basic question that you'll ever get in your life. Okay, hi everyone, hi Zeal India, hi Fantastic Fizz. Okay, the first question says, everyone grab your pen and paper and we'll start the question. Very basic, give me your answers. 2 resistances X and Y are connected turn by turn, in which case the resultant resistance will be less. The resistance will be less. What did I tell you every time? Mark the keywords. The resultant resistances will be less than either of the individual resistance. First in series, B in parallel, both series in parallel, and what am I doing? Resultant resistance is equal to the individual. Okay, B, Rohit is saying B. Ma'am, do you teach chemistry too? Till now, I only teach physics for now. Okay, Rohit is saying B. Trev is also saying parallel. Anyone else? Okay, the answer, this is a very basic question. The answer is B, parallel. Very good. Now, the answer is B. Okay, second question says, very important, this question has come in board. 4 identical resistors. How many? 4 identical resistors, each of 8 ohm. 8 ohm resistances are given, are first connected in series. So first they are connected in series with resulting resistance as Rs. Then they are connected in parallel. So in other case, the same resistances are connected in parallel. Will denote as Rp. Find the ratio of Rs and Rp. Hi Tanvi. Okay. Tell me, in series and resistances, we need to find the ratio of Rs divided by Rp. Let me know in the comment section. I told you to grab your pen and paper, okay? Let me know in the comment section which is the answer. 32 ohm, 0.5 ohm, 16 ohm or 64 ohm. Anyone? I'm waiting for your answers, guys. First, they are connected in series. So, you need to write what is the equivalent resistance formula for series. And then you can write what is the equivalent formula for resistances in parallel. Okay, Rohit is saying C. Anyone else? Hi Hanu. Hi Aditya. Good evening. Anyone else? Okay. Okay, let's see the answer. For resistances, we know we'll just add all the resistances. So 8 plus 8 plus 8 plus 8. Now, a very educated children can just write 4 into 8, which is N into our resistances, which is a shorter formula. Okay, so this is 32 ohm. Great. For RP, now the formula is different for RP. For RP, it is 1 divided by RP equals to 1 by R. Now for 4 times, so we'll just write 4. Okay, we have to be quick. So 4 divided by, what is our resistance? 8. So 1 by RP comes out to be 1 by 2. Now here is where you can make a mistake, which you will not, I know, my dear children. So RP is 2 ohm. Don't just write 1 by 2 as RP, okay? Now we need RS by RP. So RS divided by RP will be 32 divided by 2. So it will be 16 ohm. Very good. A lot of my students have answered 16 ohm, sorry. Okay, great. Trev is also right. Rohit C is also right. Okay, can we move on to the next question? Let's move on to the next question. A fuse wire repeatedly gets burnt. A fuse wire repeatedly gets burnt when used with good heater. It is advised to use a fuse wire of more length or less length, less radius or more radius. Give me the answer. Ma'am, shouldn't be the ratio 16:1 and 16 ohm. Yeah, you can write 16:1 if it's a subjective question, right? Here we are given the options. If they can give the options as 32:1 also, but if they didn't, so it's fine. Whatever, you have to work according to the options given, okay? Okay, this is a very tricky question, I will say, but very important. Let me know if anyone know the answer to this question. I'll give you a hint. The hint is, a fuse wire gets repeatedly burnt. So why the fuse wire gets burnt? Because of the resistance. If my resistance increases, that means the heat in that wire will increase eventually. That means if resistance is increasing, so link that resistance with our length as well as area. So then, an area is radius square in equivalence. So now tell me what will be the answer. C. Rohit is saying C. Muhammad Hassan is also saying C. Less radius. Okay, we'll see. Anyone else? Hi Vijay. Anyone else who knows the answer to this question? 2 of my children has given C. Let's see, can we see? Less radius, more resistance. Yes, great. But I have a question for you guys. Okay, let me just write the equation and I'll ask the question. Okay, what did we say? If resistance is more, then heating is more. So we want resistance to be less. Is that correct? Now the formula for resistance is resistivity into length divided by area, and area is pi r square. So if you are saying less radius means more resistance. But I have a question for you. Why not more length? Oh, sorry, less length. Why not less length? Why are you saying less radius? Less radius, more resistance. Yeah, more radiance is high heat. Correct. We want resistance to be low. See, they are saying a fuse wire repeatedly gets burnt. Used with a good heater. It is advised to use a fuse wire of. We should use a fuse wire of which resistance? Less resistance, so that it doesn't get burned. So now, again, think. Is it less radius or more radius? If it's less radius and resistance is inversely proportional, then resistance is more. But if the resistance is more, the wire will again get burnt, right? And we don't want the wire to get burnt. So tell me again. First that, and second, okay, if you say the radius is more now, radius is more, so resistance is less. This works. So D can be my answer. Great. But why not less length? If length is less, the resistance is also less. Then why not option B? Why not less length? Anyone? Why is the answer not less length and only more radius? Come on guys, I'm waiting. It's not that hard. Come on. Okay. No one. Or my network is slow. Okay. more radius than more length because it has square proportionality. That's great actually. That's one of the logical answers. Okay, so if my radius r square is more, my resistance is less. This is the one case. This is basically our answer. This is true. D is our answer, which is correct. The question was, why not less length? Less length, basically, Trave has given an answer that radius is squared and inversely proportional, so it has more weightage in deciding what we should do. But why not less length is, let me say my fuse wire is this long and it's getting heated in 2 seconds. But if it's half, let's say my length is getting halved, or I have shortened the length, that shortened length will again get very heated very fastly. If you just don't look at the formula, firstly, looking at the formula also, the radius has squared inversely proportionality. But if you don't look at just the formula, also use a little common sense, that the length of the wire will get heated very quickly. So our fuse again will get very heated very quickly, even though length is less. So resistance should be less, but length is less, so it will get heated very quickly, and we will not use less length. Fuse wire is meant to burn if excess current is passed. Yes, that is the correct explanation, Rohit. But what I'm trying to say is, if every time fuse is getting burnt, every time our circuit will get short, right? Our circuit will break, right? So what is the use of using a fuse which is getting burnt every time? Even if the current is not passing above the limit, it is getting burnt, let's say, because the length, we are talking about length and area, not just the amount of current that is passing. Okay, but in general you don't want the fuse to burn. Yeah, correct. We don't want every day our fuse to burn. We only want our fuse to burn when excess current is passing, not because of the area or because of the length of the fuse. Correct? Okay, hello. Okay, let's move on to the next question. Okay, this is a question that requires pen and paper. Find the current flowing through the given circuit. Now I want you to solve this. I also put a video on how to solve circuit diagrams. If you haven't watched it, please watch it. Okay, I'm waiting for your answers. This is a combination. This is a circuit of combination of resistors. The resistors are connected in parallel as well as in series. So it is a mixed circuit. Hello Sakshi, Kalda. Hello. Okay, what is the current flowing on this? Remember, all of the resistances are given and we are also given with the voltage source. What is the current in this given circuit? Let me know. I'm waiting for your answer, guys. Everyone can participate, you know. When you write your answers by your own hand, it will get memorized faster. So get a pen and paper and try to solve yourself. What is the answer for this question? What is the current flowing in this given circuit? I'm waiting for your answer, my dear children. 4, 2, okay, how many resistances are there? 4, 5 resistances are there. Can anyone solve this? Okay, I'll just wait for 10 more seconds, guys. 5, 4, 0.57 ampere. Okay, we'll see. 3, 2, 1. Okay, I'm going to solve this. Okay, first you have to see which resistances you have to solve first. Okay, so very easily we can solve these two and we can solve these two because they are in series. Can I make this diagram again? And these two will add up to 8 and these two will also add up to 8. So this is now 8 ohm and this is also just now a single resistor with 8 ohm. Okay, resistance. And this is my total circuit with 4 volt, correct? And this is 4. Now these two are in parallel, 0.5. Great. Let's see, these two are in parallel, so this will be 1/8 plus 1/8, which will be 2/8, and this is 1 by RP. Okay, again remember, do not forget to write 1 by RP when you are calculating parallel resistances. So RP will be 8 by 2, which will be 4 ohm, and then we can add this whole is now 4, and this whole is in series. You can directly add them. Let me know if I'm going too fast. Okay, 0.5. Okay, the total equivalent resistance is 4 plus 4. This is 8 ohm. Okay, great. Prince, hello. Okay, now we have equivalent resistance as well as we are given with voltage in the circuit. Now every single person will know one law by heart, which is Ohm's law. Ohm's law says V equals to I into R. We have R, we'll put it. We need to find I, and we have voltage as 4. So I equals to 4 divided by 8, which is 0.5 ampere. Every one of you were correct, yaar. You are so great. 0.5 ampere. Okay, anyone who didn't understand this question? Okay, let's move on to the next one. 5th question. Kudos to everyone who gave the answer 0.5. This is a really good question. First one is just a lame question that even CBSE asked. See, how is the electric current related to the potential difference? How we write electric current? As I, related to potential difference, that is V, across the terminals of a conductor. Ma'am, this is the lamest question to ever exist in the history of CBSE boards, okay? Or maybe I'm wrong. Okay, this is just what? This is our Ohm's law. How they are related? We know potential difference is directly proportional to electric current, and this will give our Ohm's law, which is V equals to IR. Correct? Is that correct, my friend? Okay, now second question, I have to give you the answer. Anyone who can give me the reason for second question, why should an ammeter have low resistance? This is the question that was being asked in 2023 CBSE board exams. So let me know if anyone, just at least write yes or no. Maybe the answer will be bigger. Just at least write yes or no if you know the answer to second question, why ammeter has low resistance. Guys, are the questions tough? I don't see your answers anymore. Linear what? I don't know. I am watching. Okay. Linear? Okay. Why should an ammeter have low resistance? So, my friend, we know this much, that my ammeter is connected to pass maximum current. That is correct. My ammeter is always connected in series, and it is meant to yes, okay, and it is meant to measure the amount of current that is passing in the circuit. Now if it has its own resistance, it will cause a hindrance to the current, and the current will get reduced. If my current is passing from a 5 ohm resistance, the value of current, it causes hindrance to the current, right, in the circuit. Now if my ammeter has some resistance, it will cause some hindrance in the current in the circuit as well, right? So what is the point of using an ammeter if it is going to hinder the value of current? That is why we have low resistance of the ammeter, so that total current, so that 5 ampere of current can completely pass through it, and it can measure the value of 5 ampere, and hence we know the exact value of current that is passing from that circuit. Correct? Right? Yes, I know, Trev, your answer was correct. Very good. Ma'am, are all these questions related to electricity? No, we just have 5 questions for electricity. Next one is light. We are covering all 4 chapters in this live session. So, be ready, be present. You can, okay, let's move to the next question. Anyone has any doubt in the previous question or electricity? Let me know. Thank you, motivation. It really means a lot, guys. Okay, let's move on to the 6th question. A child is standing in front of a magic mirror. she finds the image of her head bigger. Okay, let's make that child. Her head is bigger. The middle portion of her body is of the same size, and that of the legs are smaller. Okay, this is a body. Okay, this is a bigger head, and middle portion is of the same, and then that legs are smaller. Current linearly related to potential. Yes, V is directly proportional to I. So current, the graph of current is also linear, right? This is our, why can't I? So this is our graph for Ohm's law. Okay, C. Okay, see, the approach, I'm just going to tell you the approach in a very single manner. The mirror which never makes a larger image is either concave or convex. Plane mirror cannot change the size of the image. So which mirror cannot make larger size images? That is convex mirror. Convex mirror always forms diminished. So convex can't be the answer. This is always convex. So convex can't be the answer. Plane is also not the answer because plane mirror cannot increase the size of our object. So answer is what? Concave. Also, if you use your brain, if you have studied, you know concave mirror can only forms a bigger image. Plane mirror will form the image so that her body looks of same size, and then convex mirror can form diminished image. See, concave mirror can also form diminished image, but concave mirror cannot form erect or virtual image. It will always form inverted image. So it would have been mentioned that the girl is upside down. Okay, option C, because concave mirror made larger images, plane mirror makes size images. Correct. Oh, I don't know your name. Okay, Rohit. Thank you motivation. We are working very hard. We are going to come with lots of questions for you guys. This is the very first lecture. We'll come with a lots of questions for you for all the chapters. Okay, let's move on to the next question. An object is placed in front of a convex mirror. Again, highlight the keywords. Convex mirror. Let's make the convex mirror. Is this my convex mirror? And we have focal length and radius of curvature at infinity. Now, according to the Cartesian sign convention, the size of the focal length, sine of the focal length and the sine of image distance in this case will be, I just made it for you guys. What will be the size of sine of focal length and the sine of image? Okay, you are talking with all yourself. Everything, okay. Hi. Okay, give me the answer of this question. Enough talking. D. Rohit is saying D. Anyone else who thinks the answer that Rohit is wrong? Okay, Rohit is correct. We'll not waste much time on this question. The focal length we know for convex mirror. For convex mirror, the focal length is always positive. Why? Because on my axis the focal length is on the right hand side of the mirror. So we'll take, according to the sign conventions, right hand sides, any thing on the right hand side will be taken as positive. D. Everyone is correct. Okay, and image. Okay, so for convex mirror, virtual and erect images are made, which are made on the back side of the mirror. That is also on the right hand side. So these are also positive. Moving on to the next. Rays from sun converge at a point 15 centimeter in front of a concave mirror. This is our concave mirror. Okay. Where should an object be placed so that the size of its image is equal to the size of the object? Now, its focal length is 15 centimeter. Okay, tell me the answer of this question. I love optics and hate electricity. Oh, that's okay. I love electricity, to be honest, and I guarantee you, if you give it a little bit time, you'll also love it. And optics is something to love, actually. ये सारे PYQ हैं. Almost see, boards CBSE has changed the patterns to competency based questions as well. So we are trying to get as much as important repeated concepts, and we are making competency based questions according to the previous year questions. So it includes previous year questions as well as some competency based questions that we are making on our experience. Okay. B. Rohit is saying B. Okay. Tell me anyone else other than Rohit, anyone else? Rohit is doing great actually. Kudos to you. Okay. So the answer is correct. Rohit is correct. Now the size of the image. So the main thing they've asked in this question, that the size of its image should be equal to the size of the object, and at which point the size of image and size of object are same, that is at center of curvature. Now we know center of curvature is 2 times the focal length, and focal length is what? 15 centimeter. So 2 into 15 will be 30 centimeter. So the object should be placed 30 centimeter in front of mirror. Okay, moving on to the next question. If the image formed by a spherical mirror for all positions, for spherical mirror for all positions of object placed in front of it, always, see, always erect and diminished. So which mirror always produced diminished as well as erect images? See the amount of times this question has been asked, and it is the easiest question in physics, in optics, let's say. Come on guys, come on. What's the answer to this question? Concave mirror, convex mirror, or both? Which mirror produces an erect and diminished image? Anyone? Okay. We know concave mirror can produce highly enlarged image as well. So in this case, erect and diminished image can only be formed by convex mirror. Okay. So the answer for this is convex mirror. Yeah. Okay, 10th question. A spherical mirror produces an image of magnification of -1. This is a really good question. M equals to -1. On a screen placed at a distance of 40 centimeter. Screen is at 40 centimeter, so our image is also 40 centimeter from the mirror. Now, the keyword here is screen. Okay, my friend, the keyword is screen. What kind of image can only be produced on a screen? Virtual, erect, or real and inverted? Let me know in the comments. You guys are tired or something, huh? It's very hard to write in the live chat. Let me know which mirror, convex or concave, forms the kind of image that can be produced on a screen. Okay, a screen, the image that can be produced on the screen will be real and inverted. Will be real. Okay, inverted, let's save that for the last. It will be real. So the real image, convex mirror never forms a real image. Correct? So concave mirror is the one. So for first we have the answer as concave mirror, because only in concave mirror the image can be produced on a screen. Second, what is the nature of the image formed? The nature of the image. Okay, I've told you that if there is a negative sign in case of magnification, the image will be real and inverted. It will be always, it will be in case of mirrors, it will be real and inverted. The last question says, how far is the object located from the mirror? Now we know the position of image. Since it's a concave mirror, so it will be -40 centimeter. Why? Because our magnification is -1, and for -1 it is real and inverted. For real and inverted, our V will be negative. Now we need to find U, and we have magnification. We don't even need focal length for this. This will be -V by U, and minus of -40 and U, and this is -1. So U will come out to be -40 centimeter. Correct? Let's move on to the next question. And we have completed the chapter light. Let's move on to the chapter of magnetic effects of electric current, which is 11th question says, the most important safety method used for protecting home appliances from short circuiting or overloading is what? Earthing, use of fuse, use of stabilizers, or use of electric meter. Let me know the answer in the live chat, my friend. Let me know the answer. Is it earthing, or use of fuse, use of stabilizers, or use of electric meter? What is the answer? Okay, for this, see, the safety method, all our home appliances, that is our fridge or our TV, whatever, they are connected to the main meter, and before the main meter we are connecting a fuse. So every time a more amount of current passes from that fuse than required, that fuse gets burnt and it saves all our appliances from getting burnt. So our answer is use of fuse. Correct? Here. Okay, 12th question. The magnetic field inside a long straight current carrying solenoid is, it's 0, B, it decreases as we move towards its end, increases as we move towards its end, or is same at all points. Anyone who can answer this question for me? What are you guys even doing in the live session? I don't understand. Why are you not answering? Okay, no problem. I'll just give you the answers. Still, anyone? The magnetic field inside a long straight current carrying solenoid, either it's 0, it decreases, increases, what? Okay, so this is our solenoid, and we know that this is, let's say, south and north, and this will be our battery. Inside the solenoid, the field is always uniform. Inside, it's always uniform. But outside, on the outside of solenoid, the field will not be uniform, and it will be non-uniform instead. It will be non-uniform. Correct? So we are asked that inside, for inside, it's same at all points. Earthing is for shock absorption. Am I getting the answers late? Same along. Correct. It's same at all points. Earthing is for shock absorption. Yeah, earthing is like, see, when you have metallic objects or metallic appliances, the charge will reside on the outer side of the conductor. Okay, so to protect us from getting shock, we connect that third wire, the earth wire, which is green in color, so that it collects all the shock and give it back to our earth. Okay, is that fine? Let's move on to the next question, which is, this is an assertion and reason question. Force experienced by a moving charge will be maximum. Force experienced by a moving charge will be maximum if direction of velocity of charge, if direction of that charge is perpendicular to the applied magnetic field. Let's say this is my magnetic field. Okay, this is my magnetic field, and this is my charge, let's say electron. Okay, force experienced by a charged particle will be maximum. They are saying that it will be maximum if direction of velocity of charge is perpendicular to the magnetic field. Okay, what is the answer to this question? Okay, the reason they are giving is force on moving charge is independent of direction of applied magnetic force. Okay, is that correct? C. A is true, but R is C. If fuse burns, the current passes through what? I guess earth. I guess that current just stops there. The whole circuit breaks. The current don't go through in that circuit only. This is my favorite chapter, ma'am. Okay, this is a good chapter. Okay, C is the answer. The assertion is correct that when a force, because maybe you have learned this formula, maybe not. The formula for that force of charge particle in magnetic field is QVB sine theta. So sine theta, as you learned in mathematics, is maximum for 90 degrees. So what they are saying will be maximum if direction of velocity of charge is perpendicular. Perpendicular means 90 degree. So it's correct that when charge and magnetic field are perpendicular, yes, because of Lorentz force. And it's true for C. So the reason is not correct. Obviously, a charge, motion of charge is dependent on the magnetic field, the direction of magnetic field. Okay. Okay. Moving to the next question. Oh, this is a good question. First part I will do, because how will you give me the answer to this? Draw the pattern of the magnetic field lines for the two parallel straight conductors carrying current of same magnitude I in opposite directions. So let's say in this wire the current is downwards and in this wire the current is upwards. Now what? See, the hand rule which I'll use is either left hand or right hand. Just tell me which hand rule I will use. Sine is maximum for 90 degrees. Yes, very good. Which hand rule I will use? Right hand rule or right hand thumb rule or left hand rule? Anyone who can answer that question? Come on, come on. Okay, no one. I'll tell you. For the right hand rule, we'll use for this to find the direction of magnetic field in a current carrying conductor. We'll use right hand thumb rule. Now my current thumb will point in the direction of current, so it's downwards, and I'll curl the fingers in the direction of magnetic field. So this will be something like this. In the here it will be inside, and in the center they are coming outside. That's correct. They are going in, and from here they are coming out. Okay, left hand rule. Very good. In this wire the current is upwards, so for upwards my thumb will point upwards and my fingers will curl in the direction of magnetic field. So same, they are making concentric circles, but in here it's coming out and in here it's in this side they are going in. Now give me the answer of second. Show the direction of magnetic field at point O. So in here what will be the direction of magnetic field if it's equidistant? Just let me know. This is also coming out, from this is also coming out. So will it add up or it will not? Will it not? At point O, will the magnetic field because of both the wires add up or will it get subtracted? Come on guys, I'm waiting for your answer. Will they add up? Tray wire, can you confusing me? Okay, let me just tell you one thing. Study from great sources, study from someone you trust, and if you know your information is reliable, it's for both of you. Okay, I am not pointing anyone, but if you know your sources are credible and your knowledge is good, focus on just that. Just leave the noise. Okay, gamers, hi ma'am, hi. Add, yes, at the point O they will get added up. Why? Because of this wire the magnetic field is also coming outside. Because of this wire the magnetic field is also coming outside between those wires, and since O is equidistant from both of them, okay, so that's why these magnetic field lines will get added because of both wires. Okay, moving on to the next question. Last question from this chapter. State the rule. Oh, this is good. You just have to state the rule. State the rule to determine the direction of a magnetic field produced around a straight current carrying conductor. First, yes, right hand thumb rule was right. It was right hand thumb rule. Right hand thumb rule was right. Okay, let me know the answer for the first part first. Which hand rule will we use to find out the magnetic field produced due to a straight current carrying conductor, or let me just say direction of magnetic field? What is it? The direction of magnetic field. Anyone? Trev, Rohit, gamers, anyone who knows the answer to this question? It's either right hand thumb rule or left hand rule, right? A, right hand thumb rule. Okay, Rohit is saying right hand thumb rule. Come on. Okay, great. We just used this here to find the direction of magnetic field. Which hand rule we used? We used right hand thumb rule. So, to find the magnetic field produced around a straight conductor carrying current, we'll use right hand thumb rule. Okay. B, the force experienced. See, what force? Highlight the keywords always. Read the question calmly and highlight the keywords. We need to find force experienced by a current carrying straight conductor placed in a magnetic field which is perpendicular to it. Okay, these two are perpendicular. Now, which is it? B is left hand thumb rule for determining force. Okay, everyone is doing so great. I guess you are on the way to score 95 plus. This is great. A is right hand thumb rule. I am not going to write the whole. Okay, and B is Fleming's left hand rule. Just don't forget to mention Fleming's left hand rule. Okay, and this is right hand thumb rule. Okay, moving on to the next question. Next, our chapter is last chapter for physics. This is human eye and the colorful world. Let's see the first question. Oh, that's a big question. In bifocal lenses, again highlight the keywords. Bifocal lenses used for the correction of presbyopia. For this, you need to know what presbyopia is. Let me just tell you. Presbyopia is when, see, there are three kinds of defects: myopia, hypermetropia, presbyopia. In myopia, the person can't see the objects that are far away. In hypermetropia, the person can't see the objects that are very near, nearer than 25 centimeter, or near point. Cute chapter Rohit is writing. Okay, and presbyopia is someone who can't even see the farther distance or the near distance. Okay, they need help in seeing both farther objects or nearer objects. Okay, what is this? What is the answer to this question? First is these are bifocal lenses that you must know. They are made something like this, so that this is the area which you can use for viewing the farther objects. And when we read it like this. So the lower part is for near objects, mainly for reading. Now you need to know which kind of lenses we use to correct these two defects. For farther we need दूर की नज़र मतलब myopia. Correct. दूर की नज़र मतलब myopia. Rohit is saying D. Okay, so sorry guys. To see the farther objects clearly, that is myopia. For myopia, we use concave lens. And to see near objects clearly, that is hypermetropia. We use convex lenses. You should remember all this actually, but it's fine. So the upper portion should be concave lens. That is true. The upper portion is concave lens, and the lower portion is which is used for viewing near objects, that is concave lens. So upper portion is of concave lens for distance vision, and lower portion is for convex lens for near vision. So the option is actually D. Actually A is also correct. Who said A? You deleted the comment. upper portion, no, it's wrong. Okay, yes, the correct option is D, because they are writing upper portion for convex lens. Upper portion is for concave lens, lower portion is for convex lens. So D is correct. Rohit is correct. Okay, next question. Assertion and reason. When a light ray is refracted through a glass prism, remember, glass prism is different, glass slab is different. Glass prism, emergent ray is parallel to incident ray. Emergent ray is parallel to incident ray. They are saying emergent ray is parallel to incident ray. The reason they are giving is two sides of prism doing refraction are parallel to each other. Okay, let me know the answer of this question. If you know, I saw near vision and yeah. That I also got confused by that. But that was the upper part. Upper part is for viewing farther objects, so that will be wrong. Okay. Okay, I want to address this issue. This is why I'm focusing very hard on you to do not do these kind of silly mistakes. Again, I'm not pointing everyone. I was the one who used to make the most silly mistakes ever. My mom used to scold me a lot, because when in paper I used to know everything, I just used to do silly mistakes only. So do not do those kind of silly mistakes. Emergent ray is not parallel, instead it's deviated. Correct. Emergent ray is parallel in case of what? That is in case of glass slab. That is in case of glass slab. Okay, so the answer will be what? D. Rohit is saying D. Vijay is also saying D. So assertion correct. A is false, but yeah, no. A is false, but B is true. No. What? Are the options wrong? Both are false, because assertion is also false. The glass prism emergent ray is not parallel to incident ray, and reason is also wrong, that two sides of prism are never parallel to each other. So I guess something is wrong in this question, or I'm just confused. Both are false. A is also false, R is also false. Okay, moving on to the next question. I know, right? I also used to do that, but that's why, see, that's why I'm telling you guys what is the solution for this. Whenever you read a question, you mark the keywords, because when you mark the keywords, those get highlighted and our brain can visibly see the difference. So that helps us not to make those silly mistakes. We know the answer, but because of our silly mistakes, we lose marks. That hurts a lot, right? Okay. Ma'am, when inverted glass prism is parallel now? Yeah, when you connect one prism and you connect inverted glass prism, so the emergent ray can again merge together and it comes as white light out of the second prism. मेरी मम्मी तो अभी भी डांटती है. Yeah, I can get you. Okay, let's move on to the next question. A student uses spectacles of focal length C. Let me show you how to do this question without doing silly mistakes. A student uses spectacles of, now what is given? Focal length, and what is given? Minus 50 centimeter. Just write it down on your paper, minus, highlighting the minus part, minus 50 centimeter. This is what? Focal length. Okay, everything should be clearly visible to you. Name the defect. Now we need to name the defect. If you can write everything on your exam paper, this will reduce your chances of doing the silly mistakes to almost zero. Okay, Rohit, we are solving. Name the defect of vision he is suffering from. Which lens is used for the correction of this defect? Okay, the lens that is used. See how you need to see. Now, whenever we have a mirror, we have a lens, the first thing we need to see is what is the sign of the focal length if it's given. The sign of the focal length is negative, and for negative, the lens or the mirror, for both lens and mirror, concave mirror as well as concave lens have negative focal length. So here we are using concave. Now again in spectacles you can't use mirror, right? So we are using concave lens. This is the first answer. The second answer, which lens is used for the correction of this defect? We have said concave lens. Now see, we have done it inversely. Why? Because we know the focal length is negative for concave lens. Now in which defect concave lens is used? The concave lens is used in myopia. Okay, so this is the first answer. This is actually the second answer. So we have seen the defect and the corrective lens. Compute the power of this lens. So I know power is 1 by focal length, and 1 by focal length is minus 50. Do not forget to use the sign minus 1 by 50, and if you then divide it, it will be minus 0.02, and the unit of power is diopter. Correct? Minus 2 diopter. Why? This will be minus 1 by, yeah, okay, correct. He is actually right. Minus 50 centimeter. So you will not use centimeter, you will use minus 1 by 5 meter. Every time when you are calculating power, for diopter unit, the focal length should be in meter. Rohit, excellent. Okay, I was wrong. So here the power will instead be minus 2 diopter. Two things that you need to take care of this. First, you need to remember that focal length should be in meter. Then you need to remember that in power also you have to use minus sign, and you need to use diopter as units. Correct? Okay, moving on to the next question, that is 19th one. A person suffering from short-sightedness. What is he suffering from? Short-sightedness can see clearly only upon a distance of 2 meters. So he can only see clearly up to the distance of 2 meters. Find the nature and power of the lens required to correct his vision. Now, can anyone give me the answer to this question? Just give me a vague answer on what is the distance of object or what is the distance of image. Give me the answer of these two questions. Then I'll do the question. What is the object distance here and what is the image distance here? Let me know in the comment. Myopia equals to convex. No. Myopia, in myopia, we use corrective lenses, concave lenses. Nature, power of the lens. Okay. First tell me, what is the distance of object and distance of image? Then we'll see the nature. Myopia is convex lens, concave lens, not convex lens. Anyone who can tell me the object distance and image distance? No? Okay. Ow. Sorry. Okay. See, short-sightedness. Sightedness. Oh, it's fine. Just remember. How will you remember? For myopia, we use concave lenses. For hypermetropia, we use convex lenses. Okay? How to find power? Let's see. See, they are saying can see only clearly up to 2 meters. So if a person is standing here, instead of infinity, he can see only up to 2 meters clearly. So that means his far point has come nearer. Correct? Greater than 2 meters. Okay. In this case, bacha, what we'll do is, we'll take in these kind of questions, you have to take object distance as infinity, because my eyes, ideally a human eye can see clear up to infinity. So when far point comes near, that means it's coming from infinity to 2 meters. Okay, that is correct. Now I'll take minus infinity as my distance of object, and V as, because I will use a corrective lens, so what my corrective lens will do? My corrective lens will form an image at 2 meter. Let's say we imagine what this glass is doing. This is also a myopic glass. So what this is doing, instead of farther image, it's making image at, let's say, 2 meter. So my distance is 2 meter and it is minus 2 meter always. Clearly up to minus 2 meters. Find the nature and power of the lens required to correct this vision. And this is lens, so we'll use lens formula, which is 1 by V minus 1 by U. 1 by V is 1 by 2 meters minus of minus 1 by infinity, which is 1 by 2 minus 0. So our focal length is 2 meter. I forgot to put the negative sign. You don't. Your marks will get deducted. My won't. 2 meter guy is practically blind. Yeah, you can say that. Yes, ma'am. Okay, so focal length is minus 2 meter. Now, which lens's focal length is negative? Come on, this you can tell me. I've repeated 1,000 times in this just 1 hour. Convex lens has negative focal length or concave lens has negative focal length? Come on. Fast, guys. Everything, Trev, Rohit. Come on, guys. I'm counting on you. Come on. I won't tell you this answer. If you don't answer this in the live chat, I won't. Even if it's wrong, just write anything in the live chat. I won't give you the answers. I will skip this question. Which I can't actually, but okay. Nobody. Okay, sure. So the focal length is minus. For minus focal length, we use concave lenses. Concave lens as well as concave mirror has minus focal length. Are you guys playing with me or something, or my net is slow? Okay, Trev has answered concave. Thank you so much. You saved my izzat. Okay, concave lens. Concave. Everyone is now answering. Okay. So we know the nature of lens now, which Rohit has answered previously. I know. Yes, Rohit has answered. And the power of lens. Now this is in meter. Now power is 1 by F. So this is minus 1 by 2. So power will be minus 0.5 diopter. See, this question was being asked in CBSE as well. Power is 1 by focal length. Focal length is minus 2 meter minus 1 by 2. So my answer is minus 0.5 diopter. Everyone understood? Everyone understood how we calculated power, how we calculated nature? See, you know the chronological order you should know. We should calculate, we need focal length to find the power, and we can also decipher nature of lens from power, correct? So we need to find the focal length. Now we have 2 meters, which is our far point. Now far point is where my concave lens will make the image for me, okay, to help my retina. So the distance of image is 2 meter. For far point usually is infinity, so u is minus infinity in this case, and hence, my friend, this is how we find it. Okay, great, understood. Great, thank you so much for understanding. Study the diagram given below and answer the question that follows. Name the defect. This is actually the last question. Name the defect of vision represented in the diagram. Give reason for your answer. Okay, just tell me what is the defect. I'll tell you a trick, very easy, that you can find out any kind of defect just by looking at one single thing in this. Ma'am, what's the power of your lenses? It's too much actually. Probably 2 something, I guess, minus 2 something. You know, I used to study a lot, so while studying I got my power high. Okay, tell me the defect in this question. I actually, when I was studying from my mobile at one point in my life, so that's when it increased. Okay, answer the question, guys. I answered your question. I answered each of your questions. You are not answering my questions. What's the power of your lens? Oh, come on. Okay, I'm getting restless. This is the last question, guys. Name the defect of vision used, represented in the diagram. You don't have to give even the answer. Just tell me what's the defect. And don't tell me you don't know this. Guess it's call you for not. Yeah, actually. I had very small number in the starting, 0.5, 0.6 maybe. And then I didn't wear glasses and my number increased. Yes. So if my mother is watching, you are the victim. You are the one to blame, Mama. Okay. Tell me the answer. Come on, you guys are just talking to me. Give me the answer of this question. Name the defect of vision represented in the diagram. Give reason for your answer. No, guys. No one is answering my question. I'm getting ghosted here. Come on, come on. Come on, guys, I'm waiting for your answer. Yes, yes, Rohit, I have short-sightedness. Okay, you guys are not going to answer now. Okay, name the defect of vision. See, the first one thing that you need to see in this whole question to know that what kind of defect is this is the kind of lens that has been used in this whole diagram. I don't know the answer. It's fine. Everyone can't know the answer of everything. It's fine. It's fine. Don't be sad. Sorry for my humor. Okay. This is the lens we are using. Which lens is this? This length is convex lens. Correct? You should know at least this one. Okay? This is a convex lens. Now tell me, in which defect do we use convex lens? In myopia or hypermetropia? It was me, Trev, not Rohit. What? For what? Okay, sorry, Trev. It was you. That's why I'm here. Convex lens. Convex lens, convex lens. Correct. Trev is correct. It's convex lens. Convex lens is used in which kind of how do you say, defect? In which kind of defect? Myopia, hypermetropia, presbyopia. In which defect do we use convex lens? Dayanand. Hi Dayanand. Dayanand is saying hyper. Hyper? What's hyper? Hypermetropia? I know. Okay, sorry again. Hypermetropia. Dayanand is correct. In convex lens you use to correct the defect of hypermetropia. Hypermetropia. See, you in this particular question, you don't even need to see where the image is being made, front of retina, behind the retina, if the near point is moving or not. Okay. Deepika. Hi Deepika. Okay, Trev is also saying hypermetropia. Great. So, what am I saying is you don't even need to see if the image is being made on the retina, behind the retina, front of retina, or the far point is, near point is. You can just look at this lens and then you can connect the dots that this lens is used to correct this kind of defect. Hence, I know the defect of vision present in the diagram. Give reason for your answer. What is the reason? Either my eyeball is got shortened, my eyeball got shortened, or the focal length of my lens, not the corrective lens, focal length of my, let's say, eye lens gets, how do you say, increased. Focal length increased. Either my eyeball got shortened or my focal length got increased. Yes, the focus is beyond the retina, that's why there's a defect. Ideally, the image should be made on the retina. That's how we can say see properly, right? But it's the image is being made behind the retina, behind the screen. So if image is not on the screen, how will we see it? Decrease in curvature, correct. Yes, your understanding is right on point. Rohit, what's hypermetropia? Hypermetropia when someone can't see nearby objects clearly. So the near point of an ideal eye should be 25 centimeters. So my phone should be at a distance of 25 centimeter from my eye. But what happens, you might have seen your grandparents read their newspaper or phone like this. So they are increasing the distance because they have gotten farsightedness, that is hypermetropia. They cannot see nearby objects clearly, so they have to keep the phone away from them or newspaper away from them, so that the image of this object get made on the retina. In this hypermetropia, the image is being made behind the retina. Why? Either of these two reasons, either my eyeball gets shortened or my focal length increases. If the focal length of my lens will increase, the image will not get focused on the retina but behind the retina. The focus is, yes, okay. Why is it not loading? Okay, list 2 causes of this defect. These are the 2 causes of this defect. Okay, everyone, here ends our live session. They used focal lengths. What are focal lengths? Do I not know this? Okay, here ends our live session for today. We did competency based questions, we did PYQs, we did assertion and reasons, we did numericals, we did all kind of questions of all 4 chapters of physics, correct? Now this is the first lecture of our physics series. In the next live, I will also come again with all kinds of question and all kinds of competency PYQ, so that there is a lot of material that you can practice from, and I'm here. You can ask doubts, you can talk with me and everything. This question, the concept अच्छे से recall हो रहे हैं. Yeah, that's why I'm trying to revise you all the chapters in the form of questions, so that you know the PYQs also, you know how to solve the questions, how to write the questions, and you can revise the chapters as well. Here ends our live. Again, if someone, okay, there is one short request. If you have not liked the video, please like the video now. If you have not subscribed the channel, please subscribe the channel. We are putting so much effort. We are going live for you guys every day almost, and I'm also bringing you, I have a video on how to solve any electrical circuit in just 5 minutes. Is very useful. I worked very hard for that, on that for you. And also one more thing, for all other subjects. Yeah, we are doing it for all other subjects, SST, mathematics and everything. Also, I'm bringing one more video where all the formulas will be in one single video, correct? That video you must watch. It will come in 1 or 2 days, I guess, on Sunday maybe, I don't know the exact time, but I'll tell you in the WhatsApp channel. So go join our WhatsApp channel to know the notifications, to get the notifications of everything that is happening on our channel. For your 10th boards, I want you, all of you, to score 95 plus in 10th boards. I know the pressure is very real. I know you guys are you want to make your parents proud, you want to show your enemies that you can also work hard. I've been in that position. I know how that feels. That's why we all are working very hard for you guys. I already watched it. That's great actually. Thank you everyone for joining this live session. You all were an amazing student. I thank you all with all my heart, and I will keep doing hard work for you guys. I will bring you more important questions, PYQs in the live sessions, and all other teachers are also bringing very good questions for you. So keep joining our live sessions, subscribe the channel, like the video, and follow us on WhatsApp. Thank you. Bye everyone. Bye. Nobody of you liked my video. Please like the video. Bye.